Imagine you're sitting around at night having a cup of coffee, maybe a glass of wine, you're relaxing, and all of a sudden the lights go out. No big deal. You go down, you check your circuit breakers, they're fine. You take a peek out the window and you notice that your entire neighborhood's dark. You go and you talk to one of your neighbors and you ask them how long their power's been out, and it went out about the same time yours did. Then you start looking around and you're having a car problem. You can't get your car to start. Your phone's not working. This is a little out of the ordinary. So you live reasonably close to your police station. So you and your neighbor walk down, see the police station, and that's dark. The police are trying to figure out what's going on. They have no radio communication with their officers. They're trying to get a hold of emergency services. They can't reach them either. So what's going on? Well, the police tell you, go home, figure out in the morning. You do that. The morning comes and power's still out. What's going on? That's the question. So it takes you about 3 days before you start getting some answers. There's been an EMP event, an electromagnetic pulse event, and it's crippled some of the power systems, some of the distribution and transmission systems that support the power grid. The big problem is equipment's been damaged that has a long lead time. They aren't going to be able to replace some of this equipment for maybe a year. What are you going to do? This is a problem, and this is what you need to consider. My name's Terry Murch. I'm the president of TSS USA Manufacturing. We're a small business. We are a defense contractor and we specialize in high altitude electromagnetic pulse and electromagnetic pulse protection filters. EMP is electromagnetic pulse. It's generated by one of three ways. The first would be a solar storm or a corona discharge. This would create an energy mass that hits the Earth's atmosphere, couples to the magnetic field, and provides a pulse that looks kind of like a lightning bolt to your electronics. This would not hurt a person. A high-altitude electromagnetic pulse is a pulse that's created by a nuclear device that would be detonated in the atmosphere 250, 300 miles above the Earth. This would create another EMP event. Basically, gamma rays would excite the electrons in the atmosphere and cause this to couple on to power lines and again damage electronic and electrical equipment. A third way would be a directed energy weapon or a piece of equipment that's been designed to create an electromagnetic pulse that would be directed towards maybe a transformer, power lines, a system that you want to destroy or at least disrupt. EMP event basically has three components. It has what are designated as an E1, E2, and E3 pulse. The E1 pulse is the initial pulse. It's very intense. The E2 is an intermediate pulse. It's a little bit longer, and then an E3 pulse is the residual pulse. It lasts quite a bit longer. Each one has its own damaging effect. The E1 and E2 are the most intense, that do the most damage to equipment. Transformers are susceptible to an E1, E2 pulse, and E3 pulse. When the energy comes down the power line, it's a much higher voltage. Typically, medium voltage is 4,160 volts. It comes into a transformer then, which reduces that to either 480 volts or lower. When a conducted pulse comes down a power line and reaches the transformer, it damages the transformer, and it damages to a point where it cannot be repaired. Since the transformer is an absolute necessity to create usable voltage. When the damage is done to it, it must be replaced. And without the transformer, that voltage is just too large to be used from a practical standpoint. Low voltage EMP filters and hemp filters do a great job. The problem is they're on the downside or the downstream side of the transformer. High altitude electromagnetic pulse or EMP filters do a great job protecting the equipment that they are designed to protect and utilize to protect. The problem we see is those filters are downstream of the transformers, so the transformer is fully exposed to the full pulse when there is an EMP event. TSS has designed and is in the final stages of development of a medium voltage filter. The filter is rated at 5,000 volts and up to 800 amps. Its specific use is to protect transformers, whether it's military or commercial. So if there's an EMP event when the pulse is running down the power line and it hits our filter, the filter absorbs that pulse and keeps the transformer operating and healthy. The Earth has seen several events from solar storms. In the mid-1800s, there was the Carrington event, which was a pretty high intensity solar storm. It disrupted our communication system at the time, which was pretty robust. It was telegraph. Set some telegraph wires on fire, created problems in some of the offices. I understand it created some fires in telegraph offices. In today's world, where we rely on sensitive electronics, that damage would be far wider spread. That's a higher probability than most, because again, the Earth has experienced these before. There have been several events that have taken place. The other event that's a fairly high probability in today's world would be a terrorist or a nation state planning an attack on our infrastructure. That would be with a directed energy weapon, as I mentioned earlier, mounted in the back of a pickup truck or on a landscape trailer. That would be used intentionally, and there is actually a term for this called IEMI, intentional electromagnetic interference. And this is, again, a targeted attack on infrastructure to do the most damage possible and to create as much disruption in our day-to-day grid and operations, basically creating as a large blackout if possible, most likely in a regional setting. This is a little bit on the scary side. You can go on the web and you can get directions on how to build an EMP device. A high school kid could, for a couple $100, build a pretty rudimentary EMP device that he would be able to use to disrupt a local office or a small, if he's in school and he's tired of working on his computer, he might be able to shut all his computers down. For a nation state, probably a six-figure sum, they would be able to put together a fairly sophisticated directed energy weapon that they could then use to really attack our grid and our critical infrastructure. There are, again, on the web, there are directions to build rudimentary devices. It's not a terribly difficult thing to do, and if you have an electrical engineer who works for, again, a group that might be a nefarious group, he certainly would have the capability to do this. The least likely or lowest probability but highest impact event would be a nuclear device detonated in the atmosphere 250 to 300 miles up. That would affect the entire United States. The whole country would lose power. You would lose much of the grid, transformers that we depend on to convert electricity to different levels would be damaged. Unfortunately, many of those devices, many of those transformers have long lead times, 2-3 years. That in itself would create a long power outage for the country. The Defense Threat Reduction Agency has predicted that 90% of the U.S. population would perish in the first 12 months after a hemp event like that. So it's, again, where it's a low probability, it is a very high impact event. Public utilities would be at risk. Water treatment sites, sewage treatment plants, the grid, basically substations, power stations. You would lose some ability with some trucking where it would just stop running. You would also have a problem with refrigeration and food storage because you would no longer have a reliable energy source, electrical source. So, if I were doing this, I would want to attack the infrastructure that would create the most havoc. And again, water treatment would be probably one of the primary targets, but also substations. We look at it, the 2001 Northeast blackout that was caused by a single branch falling on a power line. So it wouldn't take much to create a regional blackout that would be long-lasting. The government has issued different standards. The MIL standard, which is issued by the Defense Threat Reduction Agency to protect military facilities, buildings, government agencies, and that's MIL standard 188-125, is at a much higher level. It's anticipating battlefield conditions in all events. The DOE, the Department of Energy, and DHS, Department of Homeland Security, have issued guidelines for industry to use. They're less severe. They take into account that most buildings are not going to be in a battlefield environment, that they're fixed, they're in the United States, and it's unlikely that they'll be subject to a direct attack. These make more sense for this because, again, it supports a scaled approach, less expensive and more practical to hardening those sites. In our process, we have developed a series of tests that go well above and beyond what any filter manufacturer would normally do to proof out the filter and to make sure that it's got the robustness that's required to survive in an environment that it will be operating in. EMP is real and should be taken seriously. By taking a thoughtful approach to hardening your facility, you can assess what equipment's absolutely critical to the operation, what equipment's important and necessary, and what equipment you can operate without. Once you've done that, you can take a scaled approach to protecting your assets. By adding an EMP component to your standard maintenance, you can start hardening your facility over a period of time, not at once, without incurring great cost, and make your facilities and your assets secure. By doing this, you can harden your facility and reach the level of security that you need.